Okay, folks, we're on 7-4, page 384. That's where you should be. And we are doing adding and subtracting rational expressions, and this is tougher. Because, as you know, adding and subtracting things, you need a common denominator. That can be sometimes hard to find. And I'm going to show you a foolproof way of finding the common denominator if you get stuck. And I'm going to do it with numbers first. Okay, so if I wanted to add this fraction to this one, heaven forbid, you would grab your calculator to do it, and I would too. However, it is instructive to be able to use something simpler that you're more familiar with to show you how to find something, because you will not be able to use your calculator to find the answer to algebraic expressions that need adding. You have to do this process. So, first of all, the denominators are not the same. If they are, then you just add the numerators and put it over that common denominator, right? That's going to happen to you right at the very beginning, just to try to ease you into it. These do not have the same denominator, and the denominators are huge. And it's really hard to figure out the very smallest thing that both of these go into. That's what we're trying to find. It's called the least common multiple. And that's not the same thing as a common denominator, but we want the least one so that we don't have to deal with big numbers and have extra junk hanging around. Least common multiple, we're looking for the smallest number that this goes into, that this also goes into. That's a pretty daunting task unless you do it the way I show you. What we're going to do is we're going to take 360 and prime factor it. Can you see the 10 and the 36 in there? It's a good way to start. Bust things down in a hurry, right? You see it? Yep. So 10 is 2 times 5, and 36 is 6 times 6, and 6 is our 2 and 3, and 2 and 3. Y'all following? I realize I'm going down a ways and you're having to look around, people. If you need to stand up to see, go ahead. But I don't want to erase, I don't want to go over here because I've already got that written over there. So what I've got here on this one is 2 times 2. That takes care of this one and this one. Then I got another 2 there, right there. And then I got a 3 and a 3 and a 5. Now this step right here is not necessary. I just like to keep things in order a little bit to kind of show what's happening. Then I take the 660 and I do the same thing. Wow, little revelations there. Okay. Factor, we get a 66 and a 10. It doesn't matter. Just bust it up. This is going to be 6 and 11. This is going to be 2 and 5. And these are all prime, but I got one more thing to do here on 2 and 3, right? So now what I have is a 2 and a 2, and a 3, and a 5, and an 11. Don't forget the 11. He's kind of hidden in there a little bit. Okay, everybody got that? Yep. All right, now here's how, maybe I better erase this. It looks like I'm going to have to go up here. Now here's what you do. Once you get them factored entirely, so you can imagine you're going to be factoring again today, a lot, especially denominators. Once you get them entirely factored, I guess I'll put it up here because some of you are really reaching to see. So I've got a 2 times 2 times 2 times 3 times 3 times 5. You want to keep them all separate. Don't write this as 2 cubed and 3 squared. Don't do that. Leave them all separate. 2, 2, 3, 5, 11. Okay, so those are my two numbers completely and totally factored. This is how you choose a least common multiple when you have this many factors. You write down the first one you see and cross it out. And if this guy also has one, cross it out because you only need one of the two for the least common multiple. Then write down the next thing you see and cross it out. If this also has one, cross it out. You only need one of the two. Write down the next thing you see, which is a 2. Cross it out. That doesn't have one, but I'm going to need this one. If there's only one that shows up, I'm going to need it. If it shows up twice, once here and once here, I only need one of them. Next thing I see is a 3. So I write down a 3, cross that out. This guy has one. Next thing I see is a 3. Write it down, cross it out. Doesn't have one. Next thing I see is a 5. So I'm going to write that down, cross that out. This guy also has a 5. And the next thing I see is an 11. 8 times 9 times 55 is the least common multiple. 8 times 9 times 55. What is that?
2,960.
One more time.
39.
39?
6 0.
3960. Now, see if that's divisible by 360, and then take the same number and divide it by 660 and see if it goes in there. And it's important to know how many times. How many times does 360 go into this? Then I would need to multiply this by 11 over 11. Do you see that?
Yep.
Okay. And how many times does 660 go into it?
6.
Then I would need to multiply this by 6 over 6. Then they would both have 3960 for denominators, and I would have numerators that I could add after I multiply them. Does that seem familiar?
Yep.
Even though the numbers are huge? This is how you go about choosing a common one. And then you got to figure out how many times does that go into that common one, because that's what needs to be multiplied so that this denominator is 3960. Same thing here. And then when you take 14 times 11 and add it to 87 times 6, add those two together and put it over this. Does this seem familiar for numbers if you're doing it by hand? Exactly the same thing when you're doing it with algebraic expressions. Now this first thing we're going to do is only finding that 3960. That's all we're going to do. And then we'll apply it to some fractions in a minute. I want you to practice first, just looking for the least common multiple. We have 4x squared minus 16 for one of the things. That's like saying the 360 right here. It's 4x squared minus 16 and 6x squared minus 24x plus 24. Okay, so those are the two things we're considering, and I need you to understand, hopefully in your mind you understand the concept here. These are serving the same purpose as the 360 and the 660. We're trying to find the least common multiple of those two. You see? So we need to factor them. You see the difference of two squares here? The thing I see first, though, is this.
Yeah.
Which comes down to this. If you're really trying to prime factor, it comes down to this. Right? Go to factor this now. So I'm in the process of doing this. Trying to factor things completely. Take out a 6, and I get x squared minus 4x plus 4. That's going to be 2 times 3 times. I want to find factors of 4 that add up to 4, and that's 2 and 2. It's going to be 2 and a 2, as I said. And I need both of them to be negative to make that a negative 4 in the middle. Are we good?
Yeah.
You see? It's like prime factoring, only you got to apply your algebra skills.
So are these the denominators of the
They would be if we were doing an actual adding of fractions. We are just trying to find the least common multiple of two things. But yes, these would be denominators of something. Okay? So now that I have them completely factored, here I go. I write down a 2. A 2. A 3. That takes care of the numbers. X minus 2. X plus 2. And then x minus 2 is left. So I'm going to need both of those. So the least common multiple for this thing is 2 times 2 times 3 times this times this times this. And when you go to do this in a fraction, I recommend that you leave it factored. Because, well, let's say this one up here has got the 2 and the 2 and the x minus 2 and an x plus 2. So I'm going to have to multiply, if this were a denominator, I have to multiply top and bottom on this side by 3 and this extra x minus 2. That's the part it's missing. See what I mean? And then over here, if this were a denominator on this side, this one's got a 2 and a 3, so I'm going to need a 2. It's got 2x minus 2, so I'm going to need a 2 and an x plus 2 for this fraction if it were a denominator to multiply by. Because that's the part its denominator was missing. Follow all that? Okay, let's try one. By the way, your denominators are not going to be that ugly. They just wanted you to practice this little skill of finding the least common multiple first on this kind of thing. It's not going to be as bad as all this. You'll see.
So are we gonna, after like we've gotten it down to that point, are we gonna have to like most fun?
Multiply top and bottom by what each denominator is missing, and then combine the numerators. Yes, you're always going to have to do that. We're gonna throw you in the deep end right now. Okay? So we've got 7 over 9x squared here. Plus x over 3x squared plus 3x. Now let me give you a little hint when you're doing this work. This will really, really save you if you will just listen to me for a minute. We are going to have to multiply the top and the bottom of both of these by something. You'll have to multiply the top and the bottom of this by whatever it's missing. And I recommend you leave enough space on your page so if I were putting this on a page right now, the edge of my page would be over here somewhere. This may be the top, I don't know. Anyway, we got the holes over here on the page, and this is number, I don't know, 17. Here's your column right there. I would put 17 right here and move that over. So leave yourself some space on this side to multiply top and bottom by what it's missing. It's going to be a lot better than cramming it together and trying to figure out what you wrote. So if you can remember when you go to do these, put them way out here on the line so you've got room here to multiply by what it's missing and still room over here to multiply by what this one's missing, and let it go down. Leave yourself some space so you can see what you're writing. If you can anticipate where you're headed, you can understand why we want to do this. Are you with me there?
Abby Rick, Matt Rideout, Campbell Thurgood, Aiden Alley, Boston Barchi, Caitlin Benson, Kate Burnham, Olivia Crapo, Jefferson Dye, Rob Esplin, Rachel Green, Will Harmon, Weston Jones, Katie Miller, and Tanner. Come to the office with your laptop, please.
Do you see my choice of common denominator? Do you understand how I did it? Now, I did this on purpose. See if you can follow this. This is a little bit different than what you did maybe with numbers, so kind of what we did before. But what I'm doing is I'm writing down my common denominator and putting it under one big old bar here. And I will put whatever this turns out to be plus whatever this turns out to be on top and finish it, because it'll already be over the common denominator as I choose it. Does that make any sense? Does that make any sense, Rachel? You okay on this?
Yeah.
Okay, let me try again. Let me tell you again what I'm going to intend to do.
Okay.
See if you can follow it. It's a strategy to save yourself a little bit of time, and you guys are always interested in that. All right, so y'all understand how I chose the common denominator and wrote it here? Yes, you see what I did? This is one big fraction bar because I intend to take this one and add it to this one and put it over the common denominator. I'm just facilitating that right now, putting that over the common denominator. What I'm going to do now is take this common denominator and figure out what this one was missing and multiply the top of that by it and also the bottom, but I've already got that here. I've already got the bottom right here. And I'm going to figure out what this one was missing that made this and multiply the top and bottom of that by it, but I already have the bottom here. So it's really only the tops I'm interested in. Does that make any sense? Okay. See if you can understand how this works. So I've got a 3 and a 3 and an X here. The only thing this one was missing is X plus 1 over X plus 1. Now, this one's denominator is 3 times 3 times X times X times X plus 1. And I've already written it here. Is that okay? What's this one missing? It's got a 3 and an X. It's missing a 3. It's missing another X, but it's not missing X plus 1. So it's only missing a 3 and an X. So I'm going to multiply top and bottom by 3X over 3X. But again, this is already this. So what I'm going to add up here is going to be 7X plus 7 plus 3X squared.
Okay.
Do I need to slow it down and show you why this turns out this way in a shortcut method? I can. You need to see it? You do? Okay. Let me take this away. I'll come back to this in just a minute. Do you understand why I need to multiply the top and the bottom of this by this? Who does not understand that? Everybody clear on why I'm multiplying this fraction times X plus 1 over X plus 1? I determined that this denominator of all these things that I factored out here, it had the 3 and the 3 and the X and the X. What it was missing with the common denominator that I chose was, I haven't written down the common denominator that I chose. I guess you better be able to see that. And what was it? 3X, X, that was 3 and the X and an X plus 1, right?
Yeah.
So this one had the 3 and the 3 and the X and the X, and it was missing X plus 1, and that's why I'm multiplying this top and bottom by that, because this denominator was missing that for my choice. This one over here has a 3 and an X. It's missing a 3 and an X. That's why I'm multiplying top and bottom by 3X. Y'all following me? Which leads us to this. 7 times x plus 1 plus x times 3x all over, well, maybe I shouldn't do all over. I'm slowing this down. This one would be over 3 times x times x times x plus 1. And this one would be over now 3 times x times x times x plus 1. They all now have everything they need for the common denominator that I chose, right? Since they have the same denominator, that means that I'm going to be adding 7 times x plus 1 plus x times 3x over that common denominator, which is going to be, if it's okay with you, I'm going to write it as 9x squared times x plus 1. Is that okay?
Yeah.
One more thing, and that's to clean this up here. So to clean that up, I would distribute the 7x plus 7 plus 3x squared all over that common denominator. And then just put it in order, 3x squared, or combine like terms if necessary, or whatever. It's that over 9x squared times x plus 1. Not a very satisfying answer, but the correct one. Okay? Now, I'm going to leave that answer over there, and let me show you the shortcut that you can take instead of doing this. See if you can make the link. If I come back to here, and I have chosen the common denominator, which is, I'll put that already down here, it would be 3 times x times x times x plus 1. That's what we chose for the common denominator. Do you remember this guy right here?
Yep.
Okay. This denominator, this one right here, was made up of these guys. And I've got a 3 and a 3 and an x and an x. I'm trying to decide what this denominator was missing. And it was missing x plus 1. So I really only have to multiply the numerator by what it was missing, x plus 1, because I already have the denominator here. I've already added them together, basically. So what I have now on this one is 7x plus 7. This one over here, it was missing. I take a look at it. I got a 3 and an x and an x plus 1. What it was missing from my choice is a 3x. So I need to multiply the numerator by 3x because I already have the denominator here, which will lead you to that. Do you see the shortcut?
Yeah.
I just put the common denominator under one big fat bar and decide what each denominator is missing. That's what I got to multiply its numerator by, basically, because I've already got the denominator for both of them here. Are we okay? Let's try that strategy on another one and see if you can follow through. It's not a new thing. It's just a shortcut from what you already know about common denominators and stuff. All right, let's try it. That was example 3, by the way, if you're following along. We're now on page 386, and we want to do example 4. This is what we're trying to add together. X plus 2 over 2x minus 2. Hope you can anticipate the factoring of that already. Minus negative 2x minus 1 over x squared minus 4x plus 3. Okay, we're going to add these together. First, recognize the denominators are not the same. So we have to find a common one, and we start by finding the pieces. This one factors into 2 and x minus 1. Okay with that? This one doesn't have anything we can pull out, but it factors into x minus 3 and x minus 1. Am I going too fast? Common denominator then is 2 and x minus 1 and x minus 3. Yes? Y'all see it? With the writing down things? We had 2 x minus 1s. 1 in each one. We only need 1. But we need an additional x minus 3 in that too. They only showed up once. We need them. This one has these 2 and is missing x minus 3. So I want to multiply this by x minus 3. I'll do that. I'll just write down what I want to do. So x minus 3 times x plus 2, and I'll do that in the next step. That one is missing a 2. That denominator.
Oh, yeah.
It's only missing a 2 from what I chose. So I only have to multiply by 2 over 2. Now, if you haven't been paying attention up to this point, or you're taking notes and not focusing entirely up here, you better pay attention now. This guy right here is going to change your life if you're not careful. When that's a subtract sign, you've got trouble. And you better be able to handle it. What I'm going to do is I'm going to put a minus sign right here, and I'm going to deal with it later. I'm only going to do that right now. Okay? I'll deal with that in a minute or two, but it belongs, this guy right here belongs to the numerator. We're going to push it through the numerator in the next step. That's my minus sign that is right here. You with me? Forget that now that you've written that down and distribute that. That's going to be, well, I won't distribute it. It's just going to be that 2. Don't worry about that. That's already been written down. That's 2 times negative 2x minus 1. You have to be able to keep track of all those negative stuff. I've chosen not to deal with this one. All I did is write what I wanted to multiply by here. I didn't even do the multiplying. I just wrote down I wanted to multiply. Are you with me?
Yeah.
All right. Now, on the next step, we will continue to clean up the numerator. I'm going to leave this guy factored all the time, even in the answer. Leave it factored. With one exception. Do you remember the previous one where we have 3 times 3 times x times x? You should call that 9x squared. But leave anything in parentheses in parentheses.
Oh, yeah, like,
Yeah. So I'm going to leave this alone, clear to the end of the answer. So forget about the denominator for a moment. We got to work on this. So the first thing I got to do is FOIL these together. And that's going to be x squared. And I think at your level of math, you can follow what I'm going to do. That's x squared. This is 2x minus 3x, which is negative x. I'm going to do that in my head. And the last one is negative 6. Now, in this stage right here, if I had, instead of just a 2 here, if I had, for example, x minus 1 here or something, and I had to FOIL that out, I would still FOIL those out before I distribute that negative. However, on this one, since it's just a 2, I can distribute a negative 2 at the same time without stressing my brain too hard. So I'm going to have positive 4x, that's a plus, 4x, and then a positive 2. Y'all see it? And I'm just going to, and you can do this too, I'm just going to put that over common denominator because I don't want to write the final answer yet. I don't have to write that down every time. Just keep track of it that there's a denominator there. Now I'm going to clean that up. It's quadratic, has one quadratic term, so that leads. Negative x plus 4 is 3. Negative 6 plus 2, negative 4. Over my common denominator, 2 times x minus 1 times x minus 3. Now that was a lot to keep track of. And we are not done. Because that numerator, now that it's been put together and handled all the signs and everything properly, that numerator is factorable. The one on the previous problem wasn't. I didn't even bring it up because I knew it wasn't. This one is. This one's factorable. What does it factor into?
X, and then x plus x4 plus x
Plus 4 and
minus 1.
x minus 1 over 2 and x minus 1 and x minus 3. And so now we're in the same boat we were yesterday. Cancel that. Write the final answer, which is x plus 4 over 2 times x plus x minus 3. Leave it factored. And then disallow what?
X
1. We already know it can't be 3. But this one that we lost here says it also cannot be 1. That will not happen every time. But you must check for it every time to see. And if it does factor and cancel and you don't, you leave it like this, you won't be finished and you won't get full credit. Nor will big ideas accepted. Do you follow me? This will not work out every time. This will not necessarily factor into one of these every time. Let's pretend for just a moment that this was factorable, but it factored into this. Let's pretend just for a second that it factored into this instead. Then nothing would cancel, right? But it factored. But nothing will cancel. So which one's the correct answer? The previous one is fine because nothing cancels. So the previous one is done. Or you can write it in factored form, indicating that you attempted to factor, but nothing worked. Okay, I'm going to take this back to 1 so that it looks right on the recording. These are canceled and leads to that. So you factor it to see if something will cancel. Turns out nothing does cancel. You can still leave it in factored form for your answer. But if it does cancel, you have to continue. Sometimes what you get up here, most of the time actually, most of the time that won't factor at all. But if it does, you have to do it. Get it simplified as far as possible. Okay. One last thing. I have a thing called complex fractions, which means fractions within fractions. Yay, that'll be awesome, won't it? There's two ways to solve these. I'm going to teach you only one because it's the easiest and I like it best and I'm the teacher, so that's what we're doing. There are two ways to solve this, but I'm going to show you only the best way. So example 6 has 5 over x plus 4. Over, here's your big divide sign right there, over 1 over x plus 4 plus 2 over x. We are to simplify the complex fraction. Here's the only way. You'll notice he's got method 1 and method 2. I am only going to show you method 2. I think it's method 2. Anyway, this method, watch it. What you do when you have a complex fraction is take all of the denominators. Now, not every one will have a denominator. This could have been plus 4 here. Still a complex fraction. Of the fractions, which they don't have that, but of the fractions that are in the complex fraction, find the common denominator. Can you all see from your choices that we've done today that the common denominator is x and x plus 4?
Yeah.
Y'all see that? So then multiply each numerator and denominator. Multiply the numerator and denominator by that common denominator. Now watch how I write it. I want to multiply this fraction by this, which means it's in the numerator. It's over 1.
Okay.
Yeah. And then I'm going to multiply this entire denominator by x and x plus 4. And it's over 1. It's understood. Yes.
Why wouldn't you only times the 5 over x plus 4 times? Why wouldn't you multiply only by x? Because the bottom has an x plus 4.
It will be by just x as soon as I cancel the x plus 4.
Oh,
okay. I got to multiply. See, what I'm doing is I'm attempting to multiply by something so that all the denominators will cancel out in the multiplying, which is the common denominator. If every denominator, we use every denominator to come up with this, then every denominator, when I hit it individually, is going to have something cancel. Right? And furthermore, so that you understand, I'm going to take this off of here. Furthermore, so that you understand this, I'm multiplying this monster fractions numerator and this monster fractions denominator by the same thing, which means I'm really multiplying by 1. And multiplying by 1 doesn't change anything. But it changes the way it looks, but doesn't change the value. So I'm multiplying by this over itself is really what's going on. See it? You understand?
Yeah.
And in doing so, it will eliminate every one of these crazy denominators if you're careful. That's why it's kind of clever and quick. If I multiply this fraction by this fraction, which is a 1, then I will lose the x plus 4s, right?
Yep.
Leaving me with 5 times x in the numerator. Nice. See it?
Yeah.
Down here, I have to do this one at a time because I've got 2 of them down here, so it's a distribution. If I multiply this one by this, I lose the x plus 4s.
Let's get 1.
And in that term right there, I just have an x. See it? When I multiply this one in the distribution, I multiply this one by x and x plus 4, I have
2x
plus, because it's still plus here, plus, and then when these cancel out, I have 2 times x plus 4. And you don't even have to do that in this step if you don't want it. You have what's left is 2 times x plus 4. Do you see it? That's way simpler than that was. And then we write 5x over x plus 2x plus 8, which is 5x over 3x plus 8. Sorry. And we're all done. Do we have to disallow anything in the domain?
Yes.
What?
Would it be 0?
-4 and
Oh, yeah.
0. They don't show up in this, do they? As obvious things. Those were denominators at one point, and the things that make those denominators 0 must be taken out of the domain. You need to see another one? Anybody want to see another one? Yes, no? Are you sure? All right, let's see how good you are at this. Everybody do number 12 on monitoring progress, page 387. you do number 12, see if you can follow this idea up here. Number 12 on page 387. Everybody try it. If you need help, that's why we're doing this. Let me know. I'll come help you. I'm taking this away so I've got room to work out mine. We okay? Oops.
Oh, yeah, I got food.
Same thing I got? I forgot one thing. I can cancel that 3x with that 3x, right? No! You cannot cancel these. These are terms. Do not sucker for it. This is done. Yes.
So, on the second step, why don't you just cancel the x minus 3? Oh, wait.
You better know why.
Well, this case about everything.
That top one is a factor, but the bottom one is not. Do you understand?
Yeah.
Did you get the same thing I got?
Yep.
Do you understand that it is done? There is no canceling left. 3x and 3x, they show they're both the same term, but they are terms. That's the operative word there. They are terms. Terms are not cancelable. Here's the assignment for those of you doing it on paper. Those of you leaving and not writing this down, be quiet while I write. 5 through 15 odd. 19 through 26. 31, 33, 39 to 44, and 46. And if you didn't get all that, it's written right here. You can grab what you missed as you're leaving. Do try to have a pleasant weekend in spite of this assignment. Good luck.